Hi, this is the second video on the Level 3 Algebra Essential Skills. So this is for the set of worksheets labelled Essential Skills 2. A reminder that these worksheets are designed to give you the best possible chance of being successful in your Level 3 Algebra exam. Although we don't cover every single skill that you need in your Level 3 Algebra, we give you enough here so that you can feel confident that you are going to be able to answer predominantly, most of the questions that are there. I would recommend having a go at the worksheet first, so you can download that first and print it off and have a go at the questions, or you can follow along with me and just pause the video at particular points so that you can try the questions before I go through the solutions. Okay, so we'll get started. Question 1, we're being asked to factorise the expression x squared take away 9x plus 20. So we're looking for two numbers that multiply together to give me 20 but add together to give me negative 9. So I think those two numbers are going to be negative 4 and negative 5. So that means this is going to be x take away 4 times x take away 5. Okay, and that there would be our final answer for that one. Question 2. Make x the subject of the formula y is equal to fx plus 3 over 3x. So I'm going to start by multiplying both sides by 3x. So I'll write that over here. So that's going to give me 3xy is equal to 5x plus 3. I now want to gather my x terms to one side. So I'm going to subtract 5x from both sides. That gives me 3xy take away 5x is equal to 3. And then I want to isolate my x now. So I need to factorise that first. So I can see x as a common factor over here, so if I factorise, I've got x outside my brackets, and then I'm going to have 3y take away 5 inside my brackets is equal to 3. And now I can finally isolate my x because I can divide both sides by 3y take away 5, and that gives me x is equal to 3 over 3y take away 5. Question 3. For part A, we are going to simplify this side over here. So we've got 2 root 3 squared. Now remember, that means 2 root 3 times 2 root 3. Okay, so I can do the 2 times the 2 part, which is going to give me 4. And the root 3 times the root 3 part is going to give me 3. So essentially this is going to be 4 times 3, and that is going to be equal to 12. Directly from here, I could say 2 squared is 4, root 3 squared is 3, and 4 times 3 gives me 12. Okay, for part B, we're simplifying root 8 plus root 32. So that was part A. Part B. So we want to first of all see if we can simplify root 8. Root 8 is going to be the same as root 4 times root 2, and root 4 is 2, so that's going to be 2 root 2. Remember, we're looking for the highest square factor that we can find. For root 32, the highest square factor is going to be root 16, so I can rewrite this as root 16 times root 2. Root 16 is 4, so this is going to be 4 root 2. So 2 root 2 plus 4 root 2 gives me 6 root 2. Okay, and that would be the answer for that one, 6 root 2. Okay, question 4, we're simplifying 3 plus root 5 squared plus 3 take away root 5 squared. So let's do the 3 plus root 5 squared first. So I'm just going to write this out in full. So that's going to look like that. Okay, and then I've got 3 times 3, which is 9. 3 times root 5, which is 3 root 5. I've then got this root 5 times 3, which is another 3 root 5. And then I've got root 5 times root 5 is just going to give me 5. Okay, so that is going to be 9 plus 5, which is 14. 3 root 5 plus 3 root 5, which gives me 6 root 5. Okay, I'm now going to do this part over here. So we've got 3 take away root 5 times 3 take away root 5. And that's going to be 3 times 3 is 9. We've got 3 times negative root 5 is take away 3 root 5. I've got another take away 3 root 5 over here. And then finally I've got negative root 5 times negative root 5, which is going to be positive, so it's going to be plus, and it's going to be 5. Okay, I'll simplify that as well. That's going to give me 14 take away 6 root 5. Okay, so I'm now going to add these together. So that means I need to add together 14 plus 6 root 5, add 14, add negative 6 root 5, which is the same as take away 6 root 5. And if I simplify that, I've got the 14 and the 14 bit, that gives me 28. And then I've got the 6 root 5, take away the 6 root 5, which gives me no root 5. So my final answer is going to be a rational number, and it's just going to be 28. For question 5, I'm going to be rationalising this denominator over here. Okay, so I've got 8 plus root 2 over 8 take away root 2. So to rationalise the denominator, remember I need to multiply the numerator and the denominator by the conjugate of this here. So that's going to be, I'm multiplying it by, I'm going to change that to a plus, so that's going to be root 8 plus root 2. And I need to do the same thing up here as well. Okay, so I'm just going to start working over here. So I'm going to write this out in using brackets first of all. So I've got root 8 plus root 2. Whoops. Made a mess of that there. And then in brackets I'm going to multiply it by root 8 plus root 2. And then on my denominator I'm going to have root 8 take away root 2 multiplied by root 8 take away root 2. Okay, so that's essentially what's happening here. So this is similar to a question that we had earlier, so we're just going to expand these out. So root 8 times root 8 gives me 8. And then I've got root 8 times root 2, which is going to be root 16, which is just 4. That's plus 4. Root 2 times root 8. Again, that's going to give me root 16, which is just plus 4. And then root 2 times root 2 gives me 2. So I'm just going to have that there. On my denominator, I've got root 8, sorry, that should have been a plus there, shouldn't it? Made a little error there. Okay, root 8 times root 8 is 8. Root 8 times root 2 is root 16, which just gives me 4. Root 2 times root 8 is root 16, but it's take away, so it's going to be take away root 16, which is take away 4. And then I've got a negative root 2 times positive root 2, so that's just going to give me a 2, but it's going to be a negative 2, so I've got to take away 2. Okay, so in this particular one, everything's worked out to be rational, which is nice. It's not always going to happen. So 8 add 4, add 4, add 2 gives me 18. And then 8 add 4 is 12. Take away 4 gives me 8, take away 2 is 6. So we've got 18 by 6, but we can work that out because 18 divided by 6 is just going to give me 3. Okay, so the answer to this question here is just 3. Okay, question 6, we're simplifying this expression here. I've got p to the power of 7 times p to the power of negative 4, and I'm raising that to p to the power of negative 3. Let's do the brackets part first. So that's going to give me p to the power of, and I want to add these powers together, 7 and negative 4 makes 3, so that's going to be p to the power of 3. And then I'm going to raise that to the power of negative 3, and now I just need to multiply these together. 3 times negative 3 is negative 9, so that's going to be p to the power of negative 9. In question 7, we're again sticking with indices, we're going to simplify this expression over here. So I've got 5y to the power of 2/3 and we're cubing it. So I'm essentially going to do the 5 cubed, and then I'm going to multiply it by y to the power of 2/3 cubed. So the 5 cubed bit, that gives me 5 times 5 times 5, which is 125. And then I want to do this part here, cubed. Okay, so I've already cubed the 5 bit, so it can be in front of my brackets now. So I'm just cubing this bit over here. And to do this, I've got to do 2/3 times 3, which gives me 6/3, and 6/3 is just going to be 2. So this is going to be 125y squared. And that will be your final answer. Okay, question 8 says use the quadratic formula to solve the equation 5x squared take away 2x is equal to 11. Let's start by writing down our quadratic formula. X is equal to negative b plus or minus the square root of b squared take away 4ac all over 2a. Okay, so I first of all need to make sure I've got this in the right form. So I need to make sure this is equal to 0, so I need to subtract 11 from both sides. That's going to make this 5x squared take away 2x take away 11 is equal to 0. I'm now going to write down what my values of a, b and c are. I'll do that over here. So a is 5, b is negative 2 and c is negative 11. I also always work out the discriminant before I move on. So my discriminant is going to be b squared take away 4ac, and that is going to be equal to negative 2 squared, which is 4, take away 4 times 5 times negative 11. That's going to be 4, and then we've got to take away, but I've got 2 negatives here, so that's going to be a plus. 4 times 5 is 20, times 11 is 220, and then that is going to be equal to 224. Okay, so that's my discriminant there. I can now plug these numbers into my quadratic formula. So I've got x is equal to negative b, so that's going to be negative of negative 2, which is 2, plus or minus the square root of 224 all over 2a, which is going to be 10. Okay, now you might spot that actually the square root of 224 can be simplified because 4 is a factor of 224 because it's 4 times 56. So I could rewrite this as root 4 times root 56, which is the same as 2 root 56. So I've got x is equal to 2 plus or minus 2 root 56 all over 10. And now 2 is a factor of that term, and that term there, so I can divide all of these by 2. So my final answer here is going to be x is equal to, divide that by 2, I get 1, divide that by 2, and I get 1 root 56, or just root 56, and divide that by 2, and I get 5. Okay, and that there is my final answer. Now sometimes you're asked to, it specifies that you have to give your answers separately, so I would write it as 1 plus root 56 by 5 and then 1 take away root 56 by 5. But leaving your answer like that is usually absolutely fine. Okay, question number 9 says find the range of possible values of c such that x squared plus 8x plus c is equal to 0 has real roots. So we want it to have real roots, so that means that b squared take away 4ac needs to be either 0 or positive. So it can be equal to 0, but we want it to be positive as well, so we want it to be bigger or equal to 0. Okay, if it said 2 different real roots, then it would have to be greater than 0. Because it just says real roots, we can include 0 as well, because if the discriminant is 0, we would still get 1 real root. Okay, so I'm now going to just write down what my values of a, b and c are. So a is equal to 1, b is equal to 8, and c is just equal to c. So I'm going to substitute these values into here. So b squared is going to be 8 squared, which is 64, take away, and then we've got 4 times 1 times c, which is just going to be 4c, is greater than or equal to 0. I can add 4c to both sides over here, so I get 64 is greater than or equal to 4c. Divide both sides by 4, and that tells me that 8 is greater than or equal to, whoops, not 8, 16 is greater than or equal to c. And now we usually would write it the other way around, so we will say c is less than or equal to 16. So what that's telling me, that any time my value of c, or this number here, is 16 or less, I will get real roots. Okay, question 10, we're asked to find the sum and the product of the roots of this equation here, 5x squared plus 3x plus 10 is equal to 0. Okay, so I know my sum is going to be equal to negative b by a, and I know my product is going to be equal to c by a. So let's just write down what the values of a, b and c are. A is equal to 5, b is equal to 3, c is equal to 10. We can see they're all positive. Okay, so the sum of my roots is going to be negative b by a, so it's going to be negative 3 by 5. And the product of my roots is going to be c over a, so that's going to be 10 by 5, and that's going to be equal to, whoops, 2. So the sum of the roots is negative 3/5, and the product of the roots is going to be 2. Okay, question 11 says find the quadratic equation with integer coefficients where the sum of the roots is negative 3/5 and the product of the root is 2/5. Okay, so I'm going to start by saying, well, my sum of my roots, I know that's going to be negative b by a, and that is going to be equal to negative 3/5, and the product of my roots, c by a, is going to be equal to 2/5. Okay, so I'm going to choose values of a, b and c that are going to work. So let's say a is equal to, b is equal to, c is equal to. So my value of a, I can see I've got 5 here in both of these, so I can just choose my value of a to be 5. My value of b, well, negative b is going to be the same as negative 3, so b must be 3. And my value of c, we can see, is just going to be 2. Okay, so there's my values of a, b and c. So if I write down the actual equation in the form ax squared plus bx plus c is equal to 0, I'm going to get 5x squared plus 3x plus 2 is equal to 0. And I do need to write down the actual quadratic equation itself. Okay, question 12. We're being told m is inversely proportional to n. M is equal to 10 when n is equal to 2. We want to write down a formula for m in terms of n. So m is inversely proportional to n, so the first thing I would always write down is m is going to be equal to something which we normally call k over n. Okay, so now I'm going to use this information here to work out what k is. So when m is 10, n is 2. So I'm going to substitute those values in, oops, capital N. I'm going to substitute those values in, so that's going to be 10, that's going to be 2. So I can write down that 10 is equal to k by 2, which tells me that k is going to be equal to 20. Now I know what k is, I can write down the formula, because the formula is going to be m is equal to 20 over n. Yes, remember, the whole point of this is that we're trying to link m and n together with the number. Okay, so that's what that there is going to be. Okay, question 13 says, what is the nth term of this sequence over here? So 2, 10, 18, 26, 34. I can see that it's going up by 8 each time, so I'm going to say 8n straight away. And then I can see that actually the first number in my 8 times table, 8, and this is 6 less than that, so this is going to be 8n, take away 6. Question 14. We want to find the sum of the first 30 terms of this arithmetic series. Okay, so the first thing I'm going to do is I'm going to write down the things that I know. So I know the first term, a, is equal to 7. The common difference, I can see it's going down by 3 each time, so it's going to be -3 to show that it's going down by 3. And then n, which is the number of terms, is going to be 30. I know that there's 30 terms. Okay, so the version of my formula that I need for this is this one here. I've got Sn is equal to a half of n times 2a plus n minus 1 times d. Okay, so we usually square brackets there, don't we? Okay, so I can substitute all my values that I know now. So n is 30, so it's going to be the sum of the first 30 terms, and that's going to be equal to a half of 30, which is 15. And then we're going to times that by 2a, which is 14, plus n minus 1, which is 29, times d, which is -3. Okay, so let's write down the bits inside the brackets. I've got 14 plus 29 times -3. So that's going to be -87. So we've got 14 plus -87, which is the same as take away 87. I can now calculate this bit over here. Let me just come over here. So I've got the sum of the first 30 terms again. That's going to be 15 times, and then we've got 14 take away 87, which is -73. And then I want to do 15 times -73. And you probably want to use a written method for this, but I can do this. It's -1095. Okay, so the sum of my first 30 terms, if I added all these terms together and carried on for another for 30 in total, that would give me a -1095. Okay, for question 15, we want to find the equation of the line passing through the 2 points 2, 5 and 6, -3. Okay, my first job is to work out the gradient of the line, because I'm going to write it in the form y equals mx plus c. So I'm going to write 2, 5 over here, and underneath I'm going to write 6, -3, and I can use this to work out my gradient. So remember, my gradient is going to be given by the change in y divided by the change in x. Okay, so I want to see how much of the y changed, and we can see that that has gone down by 8, so that's -8. I want to see how much has the x changed, and I can see that's gone up by 4, so that's going to be +4. Okay, so my change in y, -8, divided by my change in x, which is a +4, is -8 by 4, which is going to be the same as -2. Okay, so I can start by writing down y is equal to -2x plus c. Okay, I'm now going to choose one of these points to use to help me work out what c is. Let me choose this one over here. So when x is 2, y is 5, so I'm going to substitute that in. So 5 is equal to -2 times 2 plus c. So that's going to be -4 plus c. So that tells me that c is going to be equal to 9. I'm just adding 4 to both sides to work out what c is. So my final answer for this is going to be y is equal to -2x plus 9. Question 16, I want to factorise this expression here, 3x squared plus 7x plus 2. Okay, I'm going to use the AC method to do this. I've got AC is equal to 3 times 2, which is 6. B is equal to 7. So I want two numbers that when I add them to, they multiply together to give me 6, and when I add them together I get 7, and I think those two numbers are going to be 1 and 6. So I'll put those in there. Okay, so that means I'm going to split the middle here. I've not given myself much room to do this. So let's try and do it over here. So that's going to make this 3x squared plus 1x plus 6x plus 2. Okay, so if I factorise this part over here, that gives me x is going to be the common factor. So I've got x times 3x plus 1. And over here I've got 2 as my common factor, so I've got plus 2, and that's going to be 3x plus 1. Okay, so my answer here, 3x plus 1, 3x plus 1 is common in both of them, so I've got x plus 2 times 3x plus 1. I'll write that over here. Okay, so if I expand this out, it's good job just to check it as well. So when I expand this out, I should get 3x squared plus 7x plus 2. Okay, question 17. Write the following in the form x plus b all squared plus q. So essentially here we're being asked to write this in completed square form. So I've got x squared take away 6x plus 15. So I'll do it over here. I'm going to write that as x take away 3 all squared first, because I'm halving that. And that gives me the x squared take away 6x part, but I also get a plus 9. So I want to take away a 9, and then I'm going to add that 15 on. Okay, and if I simplify this, I get x take away 3 all squared, take away 9, add 15, and that's going to be the same as add 6. Okay, question 18, we are factorising this expression over here. I need to just have a look through if I can see if I can spot a common factor across, and I can't, which means I'm going to factorise it in 2 parts, because I've spotted there's a common factor here and these two have a common factor. So ab plus 2a has got a common factor of a, so I'm going to rewrite this as a times, and it's going to be b plus 2, and then 3b plus 6 has a common factor of a 3, so we're going to have plus 3, and then inside my brackets I'm going to have b plus 2 to give me the 3b plus 6 part. And magically b plus 2 is a factor of both, so I can write this as a plus 3 times b plus 2. Okay. Question 19, we're finding the equation that is perpendicular to the line y is equal to negative 5x plus 5 and passes through the point 10, 2. Okay, so first of all we want to find we want to write the equation in the form y equals mx plus c, so I need to know what m is first of all. So I know the gradient of this line, but this one is perpendicular. This has got a gradient of negative 5, so the line that I want is going to be the negative reciprocal of negative 5, which is going to be 1/5. So for my line, the gradient is going to be 1/5, yeah, because it's the negative reciprocal of the gradient of this line. So now I know that my equation is going to be y is equal to 1/5 x plus c. I'm now going to use this information here to help me work out what c is. So when x is 10, y is 2. So I'm going to replace the y with 2. And I'm going to replace the x with 10. So that's going to be 1/5 of 10 plus c. So coming over here, so I've got 2 is equal to 1/5 of 10, which is 2, plus c. And that tells me that c is actually going to be equal to 0. So that means c is 0. The equation of my line is just going to be y is equal to 1/5 of x. Okay, in question 20 we're writing this in completed square form. I've got 5x squared take away 40x plus 3, so you'll notice here I've got a coefficient of my x squared. So this gives us a little bit more of a challenge here. Okay, I'm going to come down here. What I'm going to do to write this in completed square form, I'm just going to factorise this part of this expression. So that's going to make it 5, and I'm just going to use square bracket just to be clear about what's going on, and that's going to be x squared take away 8x. Okay, so this bit would be 5x take away 40x, which is what matches there. But remember here, I've also got this plus 3 on the end. Okay, the reason why I've done that is now I can complete the square on this part over here. Okay, so if I complete the square on this part over here, I'm going to have, that will be x take away 4 all squared. And then that's going to give me the x squared take away 8x, but it also gives me a plus 16, which I don't want, so I'm going to subtract that 16. Close my square brackets, so this bit matches with this bit over here now. I've also got this plus 3 on the end. Okay, so now I'm going to expand my brackets again over here, so I'm going to keep this part. So I've got 5 times x take away 4 all squared. And then I've got 5 times 16, which is 80, but it's take away, so I've got take away 80, and I've also still got this plus 3. So my final answer here is going to be 5 times x take away 4 all squared, and then that's going to be take away 77. Okay, question 21. A graph has equation y is equal to f of x. Point A has coordinates 4 and negative 5, and is on the graph y is equal to f of x. We're going to transform this point A to each of these graphs over here. So for part A, the first one, we're going to transform it into y is equal to f of negative x. So because it's happening to the x, whatever we do, we're going to do the opposite of. So it's being multiplied by negative 1. So we want to divide the x coordinate by negative 1. So 4 divided by negative 1 gives us negative 4, and the y coordinate remains unaffected. So it's going to be negative 4, negative 5. Part B. Again, we've got y is equal to f of x take away 3. So 3 has been subtracted from the x. So in order to do the transformation, I need to add 3 on to my x coordinate. So that 4 is now going to become 7 because we're adding 3 to it. And again, the y is unaffected, so it's going to stay as negative 5. Part C. We've got y is equal to f of half of x. Again, this is just happening to my x. So I'm halving it, so I'm going to do the opposite of that, multiplying it by half, so that's the same as the opposite of multiplying by half is multiplying by 2. So I'm going to double my x coordinate. So instead of 4, it's now going to be 8. And again, the y remains unaffected. So for the third one, we're going to have 8, negative 5. Now, we've done this on coordinates of points. In your exam, you're quite often needing to do it on the graphs themselves. It's always helpful to do it on a point, and then from that point, you can work out what the graph is supposed to look like. Okay, question 22. We want to solve x squared take away 8x take away 20 is less than or equal to 0. Okay, in order for us to solve this inequality, we're first of all just going to factorise this part over here. So I'm looking for two numbers that multiply together to give me negative 20 but add together to give me negative 8. So I think those two numbers are going to be negative 10 and 2. So I'm going to rewrite this as x take away 10 times x plus 2 is less than or equal to 0. So now I'm going to use this to work out the critical values. So my critical values, so that would be when these are equal to 0. So in order for this to be equal to 0, x would be equal to 10. And for this to be equal to 0, x would be equal to negative 2. Okay, so the purpose of this is so that I can sketch the graph of y is equal to x squared take away 8x take away 20, and these will tell me where it crosses the x-axis or where the roots are. Okay, so I'm going to draw myself a graph over here. So I'm going to have a point that crosses at negative 2, and I'm going to have a point that crosses at 10. So my graph is going to look something like this. Okay, it's going to be a happy parabola because we've got a positive x squared. Okay, right, so my next job is to now decide what the inequalities are. We are looking for this to be less than or equal to 0. So we want the situation where the y coordinate is below here, so it's below 0. So it's all of these values here where the y coordinate is below 0. So what we're looking for is everything between these 2 points over here, okay? And I need to make this a solid circle because this isn't a strict inequality. It can actually be equal to -2 and 10. So I now want to specify all the values between -2 and 10. So the way that I do this, I can write this as a single inequality because it's just one region. So I've got -2, 10, and we know that x is going to be between those, and I'm going to have my arrows pointing this way over here, and if I read that out, I've got x is greater than or equal to -2 but less than or equal to 10. Okay, and that's describing that region there, and that will be the solution to this equation, to this inequality. Okay, in question 23 we are simplifying this algebraic expression here. So I've got x squared plus 8x plus 15 over x squared take away 9. Okay, so I can't see any common factors anywhere, okay, across all of these different terms. So what I'm going to do is I'm going to factorise the numerator and factorise the denominator. Okay, so if I factorise the numerator, I'm looking for two numbers that multiply together to give me 15 and add together to give me 8. So I think that's going to be 3 and 5. So I've got x plus 3 and x plus 5 on my numerator, my denominator, and you should spot that I've got a difference of 2 squares over here with x squared and 9. So that's going to be x plus 3 times x take away 3. Okay, so now that I have factorised them both, I've got two things that multiply together here, two things that multiply together give me here. So I'm looking for a common factor in both of them, the highest common factor, and I can see that the highest common factor is going to be x plus 3 on both of them. Okay, so I'm going to divide the numerator by x plus 3, and I'm going to divide the denominator by x plus 3. Okay, so that gives me x plus 5 over x take away 3. Okay, so that's going to be my answer for that one there. I can't simplify that any further. Okay, question 24, I want to write this in its simplest form. Now I don't think I've got enough space to do that here, so I'm just going to do it on this over here. Okay, so I've got x over x plus 2 plus x squared over x plus 2 all squared. Okay, so in order for me to add these together, I need to have a common denominator. Okay, so I need to find the lowest common multiple of both of these, and I think the lowest common multiple is going to be x plus 2 squared. I've already got it on that one, so I just need to get it on that one, and the way that I'm going to achieve that is by multiplying that by x plus 2 squared. Sorry, by x plus 2. So I'm going to put x plus 2 squared, and I've had to multiply by x plus 2 to get that, so I need to do the same thing to the numerator, so that's going to become x times x plus 2. Okay, so these two fractions mean exactly the same thing. I've just now given this a denominator of x plus 2 squared by multiplying the numerator, the denominator, by x plus 2. On this fraction I don't need to make any changes because that's already x plus 2 squared, so this is just going to stay as x squared over x plus 2 squared. Okay, so now we've got a common denominator, I can add these together. So I can write it as a single fraction. I'm going to have x times x plus 2 plus x squared on my numerator, and my denominator is going to be x plus 2 squared. Right, so let's tidy this up a little bit. So on the numerator, I'm going to multiply this out because I want to try and simplify what I've got here. Okay, so on my numerator, x times x is x squared, x times 2 is 2x, so I've got x squared plus 2x plus x squared and then my denominator can stay factorised as x plus 2 squared. Finally, I'm going to add these together, so that gives me 2x squared plus 2x over x plus 2 squared. And I've just noticed actually this has got a common factor here and here. 2x is common to both of them, so I'm just going to now factorise the numerator. Okay, so if I factorise the numerator, 2x is going to go outside of my brackets, inside my brackets I'm going to have x plus, and then that's going to be 1. Okay, so 2x times x is going to be the 2x squared, 2x times 1 gives me the 2x, and that's going to be all over x plus 2 squared. Okay, and that is as far as I can go. There's no common factors anywhere now, so that there would be my final answer. Okay, finally, question 25. We're being asked to solve algebraically the simultaneous equations y is equal to x squared take away 2x take away 5 and y is equal to x plus 5. Okay, so we're looking for a value of x and y that works in both sets of equations. Okay, right, so the first thing I'm going to do, because y is equal to this and also y is equal to this, that tells me that these two things must be equal to each other. Okay, so x squared take away 2x take away 5 must be equal to x plus 5. Okay, and all I'm doing here is I'm replacing that y with x plus 5. Okay, I've just written it the other way around. Okay, so I'm now going to, well, I can see this is a quadratic equation, so I'm going to make it equal to 0. So I'm going to subtract x from both sides, but I'm also going to subtract 5 from both sides. So I'm going to do that in one go. So I've got x squared take away, instead of 2x, we're subtracting an x, so it's going to be take away 3x. And then instead of negative 5, or take away 5, we're going to subtract another 5. So that's going to be take away 10 is equal to 0. Okay, I'm now looking to see if this factorises. If it doesn't, I could use a quadratic formula, but I'm hoping this does factorise because that will make it a little bit easier. Okay, and I can see that actually two numbers that multiply together to give me negative 10 but add together to give me negative 3 are going to be negative 5 and 2. So that gives me x take away 5 times x plus 2 is equal to 0. Which means I'm going to have two solutions here. I'm going to have x is equal to 5 or x is equal to negative 2. Okay, so I've now got two possible solutions for x, but I now need to also, because these are simultaneous equations, there's going to be two sets of solutions, a set of solutions for x and y here and a set of solutions for x and y here. So I now need to work out the y. So I can see, if I use this equation here, I know that the y is always going to be equal to x plus 5. So if x is 5, then y must be 5 plus 5, which is going to be 10. Or if x is negative 2, then y is going to be negative 2 add 5, which gives me a positive 3. So y is going to be equal to 3. Okay, so I've got, I'll call this x1 and y1, and I've got x2 and y2 over here. Okay, so these two come together as a pair and these two come together as a pair, but that there would be my final answers. Okay, I hope you found that video useful. Please do make sure that anything that you're not sure about or you couldn't work out, then go away and just practice that a little bit more. Use some of the resources that you've got to practice things. Go back, make flashcards for anything that you are worried that you might forget about. Best of luck with your level 3 algebra exam, and I look forward to seeing you again soon. Take care.